So we next need to talk about a device called an electroscope. I have gone to Walmart and I've collected all of the things I need to make one. A plastic cup. I have here a pie pen, so you can make a cupcake. I have smashed its aluminum foil. I have a paper clip, and dangling from the paper clip I have 2 strips of aluminum foil. Isn't that nice? All right, and all I did is I hooked them. I basically speared them on there. Okay, so hopefully this works. This is a Walmart special electroscope. That's not good. It's not supposed to do that. All right, hold on a second. My cup may have a problem. All right, hold on, I'm going to pause this. I need, my cup is charged. I don't want my cup to be charged. I want it to be neutral, so I'm going to pause this. I apologize for that brief intermission, but what we had there is my cup, when I put it in there, the fins started moving towards the wall. And the reason why the fins started moving towards the wall is because they, the walls were charged. So when I took the cup off the stack, apparently I unfortunately or unwittingly charged it, right? Because we rubbed 2 things together, so that wasn't a great move. So now I have them stuck back together again. How did I discharge it? I used the defensive strategy of I just simply rubbed it on a metal pole, and then I washed it out, okay? Which is unfortunately going to lead to bubbles, which make it harder to see the little fins inside. But you do remember what's inside. It's 2 metal fins, which are now pretty close together. And they should be pretty close together. So now I'm going to put them on top of here. And I'm going to take my balloon, and I'm going to rub it really hard. So I'm rubbing the balloon. You guys can't see that. Rubbing the balloon. I'm doing the official rubbing together. So right now, electrons are jumping on this balloon. They have nowhere to go because it's not a conductor. It's an insulator. So as I bring this thing close, you're going to see something strange. The 2 fins move apart from each other. When I move back, nothing. When I move back close together, they move apart. Back, we go back to normal. Yep, back. Oh. We're going to call this induction. Okay, induction. So what's going on here with induction? Well, what's going on is as I get close to the top, the electrons are fleeing the top and running down into those fins. When they run down to the fins go, whoa, I don't want any part of this. But they're not really charged because when I move it back, the electrons run back up to the top because they don't want me to stand next to each other on those fins either, right? That makes sense? So as I bring the electrons up close to the top, the fins spread out. When I bring it back, nothing. All right. So that's induction, okay? Now this device I'm playing with is called an electroscope, and I'll give you a better version of what they should look like, the non-Walmart version later. But if I rub it some more, get it really charged, and then I do this, I touch it. I'm going to go ahead and touch it. Oh, I'm touching it now. It's got lots. I'm trying to put as much charge as I can on there. Oops, not enough. Hold on. Charge. Get some charge. Now you'll notice they're still apart. What's going on? Why are they still apart? Why are they magically still apart? My balloon is way over here. I'm going to throw it that way. It's gone. So why are they magically apart? It's because they're still charged. Okay? All right. We're going to do this with diagrams, and then you're going to have to do it with diagrams as part of the worksheet. So here we go. So a real electroscope ends up looking like this. It has a metal ball on top. It's got a stick going through, usually a black stopper, one of those rubber stoppers you got in chemistry. It goes down a little farther. There's usually some sort of a clip, fancier looking clip, not just a little hook on the end of anything. And then you put 2 leaves of gold foil. Isn't that nice? And then you have a beaker, and the beaker is glass, so hopefully it doesn't carry any charge. It's certainly not conductive of charge. And this is what a regular electroscope looks like. And so what happens when I bring a negative thing close to it, which is what I did with the balloon, near the top, we got plus, minus, minus, plus, and then we got the post, and then the fins down here are plus, minus, minus plus. And so what happens is the electrons, sensing the negativity of this thing, these two electrons here would start to drift downwards. And so when that happens, I end up with excess of pluses on the top. I end up with an excess of minuses on the bottom. When you have an excess of minus on the bottom, these two repel each other, and so the legs come apart. Okay, because they're repelling each other. And so that's what we saw with our own eyeballs. When I pull it back away, because there's not excess charge, because the charge is still neutral, these electrons flow back up here, and the thing ends up being back to neutral, and the legs come back together again. Now, in the case where I actually touch it, the electrons jump off. Now, when electrons jump off, the electrons flow down here, because they want to get away from this negative charge. There's also negatives up here. And so what happens is the legs swing apart, but then when I pull this away, this thing is still negative. So as it's still negative, the legs remain apart. Does that make sense? All right. So that's how an electroscope works, and that's how these little management. So what I'd like you to do is example. It says on the blanks below, we're on 9.1, by the way, on the back of the page. On the blanks below, place a letter of the diagram that best represents the charge of an electroscope during each of the procedures described. 1. A positively charged rod is brought near but not touching an uncharged electroscope. So try that one out. Hit pause. I'll give you the answer in 5, 4, 3, 2, 1. Okay, give me the answer. So hopefully you pause it long enough to think about it and actually do the problem. So I have a neutral electroscope, which starts off vaguely being plus, minus, minus, plus, and then the two legs together, plus, minus, minus, plus. All right, so then I bring up a positively charged rod. Boom, positively charged rod. The electrons here flee down here. And so my new electroscope is going to look like electrons don't flee. The electrons flow this way up. My apologies, there we got that. They flow into this. So I end up with extra negatives on top, and I end up with extra. And not working. That's good. Small delay in the universe. Okay, positives on the bottom. And so a set of choices. This means that D is that's what happens when you have a positive rod next to a neutral electroscope. Right? This is temporary. As soon as the rod goes away, it's done. Now, I want to also point out something that confuses people. These two are minus signs, not an equal sign. Yes, yes. Years of teaching, yes. That doesn't mean equal. That means minus sign. When we say equal in electricity land, we're going to say plus and a minus next to it, meaning that is neutral, right? Because it's just me pluses and minuses, okay? Everybody try number 2 if you haven't tried it yet. And I will do 2. So pause it, and I will do 2 in 5, 4, 3, 2, 1. I have a glass rod. It is charged positively by rubbing it with a cloth. That means a cloth, by the way, is what? If I scraped electrons off this to make it positive, the electrons are now sitting in the cloth, assuming I don't ground it in some fashion. Then it says the cloth is touched to the electroscope. So now I've got my electroscope, which was neutral. I'm going to throw the rag on top of it. When I do that, some of those are going to jump off. And when they jump on my electroscope, which is metallic, the electrons are going to run to the legs to get away from this negative charge. So you're going to end up with negative, negative, negative. Where it's touching the electroscope, those negatives jumped off, and I've got negatives down here as well. And yes, the legs stay apart. And by the way, if I move it away, I still end up with a negative electroscope. And so my correct answer in this case is C. All right, so now you need to do assignment number 9 dash, give me a second, 9-4. Okay, so try the problems on that one. You can't do the very last problem, so try out those 9 problems. And then I will start the next video in reference to that.